graphing a quadratic equation. The standard equation for a quadratic equation is f of x equals ax squared plus bx plus c. The y-intercept for a quadratic equation, which will be a parabola, the y-intercept is at c. The axis of symmetry for a parabola is x equals negative b over 2a. And the vertex of a parabola, x equals negative b over 2a, and then we'll solve for the y value for the vertex. The direction of a parabola is either up if a is greater than 0, or the direction is down if a is less than 0. Title of the first section is Graphing a Quadratic Equation. In this section, we'll graph a quadratic equation, which will be the shape of a parabola. The first equation, and only equation for the section, f of x equals 2x squared minus 8x plus 9. Using the previous equations and formulas, we can find out information from the quadratic equation, and then we can graph. The y-intercept for a quadratic equation, y equals the value of c, which is the last number, so y equals 9. We'll also have the axis of symmetry. Axis of symmetry will be the line down the middle of the graph that makes the graph symmetrical. This will be x equals negative b. B in this case is negative 8. So we'll have negative 8 over 2 times a, or 2 times 2. Negative 8 would be positive 8. 2 times 2 would be 4. 8 divided by 4 would be 2. So the axis of symmetry would be at x equals 2. For the vertex, vertex is x equals negative b over 2a, which is the same as the axis of symmetry. So the vertex x equals 2. And for the y value, we'll solve for y by plugging a 2 in to the original equation, and f of x equals, when we solve, f of x will be the y value for the vertex. So solving, we'll have y equals 2, and in place of x, we'll plug in 2. So we'll have 2 times 2 squared minus 8 times 2 and plus 9. Simplifying, we'll have y equals, following PEMDAS, we'll do exponents first before we multiply. So 2 squared would be 4, 4 times 2 would be 8. Negative 8 times 2 would be negative 16, and plus 9. Simplifying further, addition, subtraction, we'll do the same time from left to right. So 8 minus 16 would be negative 8, and plus 9 would be 1. So the vertex x equals 2, y equals 1. We can write that as a point 2, comma 1. And the last part before a graph is the direction. Direction will either be up or down. Looking back at the original question, which was 2x squared. 2 is the value of a, which is positive, so this parabola will open up. From here we can graph. We can draw the vertex, which is 2, comma 1. The first part we found was the y-intercept. The y-intercept is at 9. The axis of symmetry If you want to, you can put a dashed line down through x equals 2. This line will make the graph symmetrical on the left side and right side of that line. And the direction for the parabola goes up, will pass through the y-intercept. At the vertex, the graph will turn around. So drawing the parabola through the y-intercept, through the vertex, and up to the other side, that would be the graph for the section. Title of the next section is More Graphing Quadratic Equations. First equation and only equation for the section is g of x equals negative x squared plus 2x minus 6. First equation we can find, or first information, is the y-intercept. The y-intercept again is the last number, which would be y equals negative 6. Next part, we can find the axis of symmetry. The axis of symmetry again is negative b over 2a. X equals. So negative b would be negative 2 over 2 times a. A in this case would be negative 1. So we'll have negative 2 over negative 2, which would equal positive 1. The vertex for the quadratic equation or the parabola. Vertex again is the same as the axis of symmetry. X equals negative b over 2a, or in this case x equals 1. And to solve for the y value, we'll take x equals 1 and plug it into the original equation. So we'll have negative, putting 1 inside parentheses to keep it separated, squared, plus 2 times 1 minus 6. Solving from here, again we'll do exponents first before we multiply by negative 1. So 1 squared would be 1, times negative 1 would be negative 1. 2 times 1 would be 2, and minus 6. And again, we'll add and subtract from left to right. So y equals negative 1 plus 2 would be 1. 1 minus 6 would be 5. So y equals negative 5. Writing this as a point, we'll have the x value of 1 and the y value of negative 5. Last part we can find before a graph is the direction. Direction will go either up or down based on the value of a, the number in front of x squared. Looking back at the original question, negative x squared, a is a negative 1, so this parabola or quadratic equation would open down. Graphing from here. We draw the y-intercept, which is at negative 6. The axis of symmetry is at x equals 1. The vertex is at 1, negative 5. And the direction goes down, so we'll go through the vertex, through the y-intercept, and draw the quadratic equation for the question. Title of the first section is Find the Maximum or Minimum Value. In this section, we'll find the maximum or minimum value for the quadratic equation. The definition for this section, or what we're looking for, is the y value of the vertex. For every quadratic equation or parabola, the y value will either be the maximum or minimum value. First equation we'll look at is f of x equals x squared minus 8x plus 2. So to find the maximum or minimum value, we'll find the vertex, and our answer will be the y value of the vertex. The formula for the vertex, if you remember from previous section, we'll have negative b over 2a, and that will be the x value for the vertex. For this equation, we'll have negative, b is negative 8, so we'll have negative 8 divided by 2 times a. A is the number in front of x squared, which would just be 1. Negative 8 would be positive 8, divided by 2, which would be 4. So the x value is 4. To find the y value, we can take 4 and plug it back in to the equation. So we'll have 4 squared minus 8 times 4 plus 2. Solving for y, 4 squared would be 16. Negative 8 times 4 would be negative 32, and plus 2. 16 minus 32 would be negative 16, plus 2 would be negative 14. So the value we're looking for is negative 14. To determine if it's a maximum or minimum, we'll think about the graph of this quadratic equation. This is a positive x squared. A positive x squared, the parabola would open up. If you have a parabola that opens up, it has a lowest point. That lowest point would be a minimum. In this case, that minimum would be negative 14. So the answer to the question would be minimum equals negative 14. Second question and last question for the section. We have g of x equals negative x squared minus 9. And again, we'll find either the maximum or minimum for this equation, which again is the y value of the vertex. To first find the vertex, we can find the value of x, which again is negative b over 2a. So we'll have negative. B is the coefficient in front of x. We have x squared, which would have the a, minus 9 would be the c. There is no x in the middle, so in this case the b will be 0. Divided by 2a. A again is the number in front of x squared, which would be negative 1. So in this case we'll have 0 over negative 2, which would just be 0. To find the y value, we'll take the x value and plug it into the original equation. So we'll have negative 0 squared minus 9. Y equals 0 squared would be 0. Negative 0 would still be 0. So we'll have 0 minus 9, which would equal negative 9. So the maximum or minimum value is negative 9. To determine if it's a maximum or minimum, looking at the original equation, we had negative x squared. If you remember from previous sections, negative x squared, or a negative value of a, the parabola would open upside down, which means the parabola has a highest point on it. That highest point or maximum would be negative 9. So the answer to the question would be maximum equals negative 9. Title of the last section today is Find the Domain and Range. If you remember from previous sections, the domain will be the x values and the range will be the y values. The definitions for this section: domain. For all quadratic equations, domain will be all real numbers. Since all quadratic equations will have a parabola that opens up or down, the x values, which are the domain, you can use any real number to plug into a quadratic equation. The range will either be y is greater than or equal to the minimum value, or y is less than or equal to the maximum value. For a quadratic equation or a parabola, you'll either have a smallest point or biggest point for the y value. The range will have to be greater than or equal to the minimum value, or less than or equal to if it's a maximum value. First question and first equation: f of x equals x squared minus 10x minus 1. To find the domain and range, we want to first find the minimum or maximum value, which again is the vertex or y value of the vertex. Find the x coordinate of the vertex first. X equals negative b. B is a negative 10, so we'll have minus a minus 10 over 2 times the value of a, which is 1. Minus a minus 10 will be plus 10, divided by 2, which will be 5. Solving for y, we can take x equals 5, plug it into the original question. So we'll have 5 squared minus 10 times 5 minus 1. Simplifying, 5 squared will be 25, negative 10 times 5, negative 50, minus 1. Y equals 25 minus 50 will be negative 25, minus 1 will be negative 26. So the y value we'll have is negative 26. For the domain and range, domain, again for all quadratic equations, domain will be all real numbers. For the range, we'll have y and either greater than or less than. Determine which one it is, the minimum or maximum value. Looking back at the original question, we had a positive x squared. A positive x squared again means the parabola opens up. If the parabola opens up, that means we'll have a smallest point or minimum value. That minimum value is negative 26. So the range, all the numbers have to be greater than or equal to negative 26. So our domain is all real numbers, and the range, y, greater than or equal to negative 26. And the last question, second question for this section. Equation is g of x equals negative x squared plus 12x minus 28. Solving, we can first find the vertex, or the x value of the vertex. So x equals negative b, which would be a negative 12, divided by 2 times a. A would be negative 1. So we'll have negative 12 divided by negative 2, which would be positive 6. Solving for y. Plugging the 6 into the original question, we'll have negative 6 squared plus 12 times 6 minus 28. Simplifying, we'll have y equals 6 squared will be 36, and then multiplying by negative, we'll have negative 36. 12 times 6 would be 72 minus 28. Y equals negative 36 plus 72 would be positive 36 minus 28 would be 8. And again, for the domain and range values, domain will have all real numbers. Every quadratic equation, all real numbers means you can use any x to plug into the equation. For the range, we have a y value of 8, which could be a maximum or minimum. Looking back at the original question, we had negative x squared, which means the parabola will open upside down. If it opens upside down, we'll have a maximum value, highest point on the curve, which means the 8 is a maximum value, which means all the other values have to be less than or equal to 8. So the domain would be all real numbers, and the range would be y is less than or equal to 8. Finding solutions by graphing. Solutions will be where the equation or the graph, the y value is equal to 0, or where the graph crosses the x-axis. There are 3 types of answers. 2 solutions would have the graph cross the x-axis twice. 1 solution would have the graph cross the x-axis once, or the vertex is on the x-axis. And no solutions, the graph would not cross the x-axis at all. Title of the first section is Finding Solutions by Graphing. In this section, we'll graph quadratic equations and find the solutions by using the graph. First equation, x squared minus 6x equals 0. To solve this equation, we can change it into an equation and we can graph. Since the equation is equal to 0, we can write the quadratic equation f of x equals, using the equation x squared minus 6x. Once we graph this equation, we can find out where this equation is equal to 0, or crosses the x-axis, and that would be the solutions to the original equation. graph of this equation, we want to find the vertex. We can find the x value of the vertex. If you remember from previous sections, the x value of the vertex is negative b over 2a. So we'll have negative. B is the coefficient in front of x, which is a negative 6. So we'll have negative 6 divided by 2 times a. A is the coefficient in front of x squared, which is 1. Negative 6 would be positive 6 divided by 2, which would be 3. So the x value of the vertex is 3. To find the y value, we can take the x value and plug it into the equation to find the y value for the vertex. So we'll have 3 squared minus 6x, but instead of x, we can plug in a 3. Solving for y, 3 squared is 9. Negative 6 times 3 is negative 18. So our y value would be negative 9. Putting the x and y together, the vertex of this graph would be 3, negative 9. We can also find the y-intercept. The y-intercept, if you remember, is equal to the value of c. Value of c is the last number on the equation. If there is no number, the y value would be 0. Using the vertex and the y-intercept, we can graph. The vertex is at 3, negative 9. The y-intercept is at 0. And the direction this parabola opens up, since we had a positive x squared. So sketching the parabola, we can go through the y-intercept, through the vertex, and the graph will turn back around. We're not sure exactly where it crosses yet, so we'll stop the graph right there for right now. Keep in mind we're solving for when this equation is equal to 0 or when it crosses the x-axis. We have one answer already. Since the y-intercept is at 0, we know one answer would be x equals 0. To find the second answer, we can use the axis of symmetry, which again is the line down the middle of the graph that makes both sides symmetrical. Once we know one answer, this answer is 3 spots away from the axis of symmetry, which means the other 0 is also 3 spots away from the axis of symmetry. Both of these solutions will be exactly symmetrical on both sides. And if you want to, you can continue the graph. Counting the numbers over, this would be a value of 6. So our second solution for the equation would be x equals 6. So there's 2 solutions for this graph. The graph crosses the x-axis twice. First solution, x equals 0. Second solution, x equals 6. Second question we'll solve, and last question for the section. Equation is x squared plus 6x plus 5 equals 0. Again, if you want to, you can rewrite this as an equation to graph f of x equals. Since the equation is equal to 0, we'll just take the left-hand side. F of x equals x squared plus 6x plus 5.